Sharing my screen. Okay. Okay, the question is establish a 95% confidence interval for two mean difference from the previous example. Okay, remember it was x1 bar. The x male bar was 2.73 minus 2.79 minus for 95%, the alpha level will be 0.05. So if the alpha level is 0.05, remember for the double-sided, we pick up the next one because we split alpha level into half. We will have the critical value as 1.96 in the confidence interval as well. So this is going to be 1.96 right here. And within the square root, sigma 1 square, remember sigma 1 square was 0.02, and the sample size, the first sample size was 25. And the second one was 0.015, and that's divided by 21. So this is the lower bound, and this is within the square root. Okay, and let's equal mu 1 minus mu 2, or mu male. I'll have it male and female. Male and female. Let's equal. I'm gonna copy the lower bound. Yeah. Copy. Place it right here. This is. Yeah, this is a plus right here. So the lower bound, if I perform the calculation, and the lower bound would be, let me see, the lower bound, 2.73 minus 2.79 minus 1.96 times 2 by 25 plus 15 divided by 21. Okay, the lower bound I find minus 0.1339. That's the lower bound. Mu male minus mu female, and the upper bound 0.0139. Okay. Box. Yeah. There you go. That's the confidence interval. If you have a double-sided hypothesis and you're somehow given the confidence interval, you can easily test the hypothesis without even bothering the calculated statistic or anything. You just look at the confidence interval, whether the confidence interval is including the zero value. If the zero value is within the interval, then you do not reject the null hypothesis. If the lower bound is negative and the upper bound is negative, or the lower bound is positive and the upper bound is also positive, so since it will not include the zero value, then in this case you will reject the null hypothesis with alpha level of significance. Okay, I need to tell you now, give you the interpretation of this confidence interval and tell you what you can do with the confidence interval. We are 95% confident to say that the main difference between male's GPA and females GPA is at least minus 0.1339 and at most 0.0139. The other thing is, if the hypothesis are H null is the null hypothesis, mu male equals mu females against versus H1, mu male is not equal to mu female, with alpha 0.05 level of significance. Then it's easy to tell from the confidence interval whether to reject the null hypothesis. In our example, since the confidence interval is not consisting of the zero value, is consisting the zero value, we do not reject the null hypothesis. Okay, so it's easy. If you have the confidence interval already calculated, you just look at the lower bound and the upper bound. If the lower bound is negative and the upper bound is positive, and you do not reject the null hypothesis. But if you have a negative lower bound and upper bound is negative, so the zero value will not be included within the interval, and you do reject the null hypothesis. Or you might have a positive lower bound and positive upper bound, and in this case, you will not include the zero value within the interval, and then you will end up with a result, no rejection, or rejection. You do reject the null hypothesis with alpha level of significance. for double-sided hypothesis. Let's have another example from the book. Okay, the book we're following for this lecture. Yeah, there you go. Let me see. Yeah, there you go. There is an example 9.1. I'm going to copy the example, work it myself with you within the lecture. Copy, place it into my lecture note. Yeah, there you go. Okay, there you go. This is the example. Let's read the example. A study using two random samples of 35 people each found that the average amount of time those in the age group of 26 to 35 years spent per week on leisure activities was 39.6 hours. And those in the age group of 46 to 55 years spent 35.4 hours. Assume that the population standard deviation for those in the first age group found by previous studies is 6.3 hours, and the population standard deviation of those in the second group found by previous studies was 5.8 hours. At alpha equals 0.05 level of significance, cannot be concluded that there is a significant difference in the average times each group spends on leisure activities. Okay, so let's start the solution by presenting first the null hypothesis and the alternative solution. Okay. Okay, the null hypothesis, the null and the alternative. Let me establish both hypotheses because we are trying to find out whether there is a difference. So if you see that statement, whether there is a significant difference, you need to establish the hypothesis as double-sided. So this is going to be mu1 is not equal to mu2, and mu1, the null hypothesis will tell you there is no difference. Look, the null hypothesis will be established. There is no difference because mu1 equals mu2. And in the alternative hypothesis, we established there is a difference because mu1 is not equal to mu2. So the alpha level of significance is given as 0.05, and the critical value, since this is a double-sided, you can easily have the critical value as 2. You will have two critical value, 1.96 on the left side minus 1.696, and the right side you will have also 1.96. Okay, look here. So the alpha level is 0.05. So you split it into two halves, and you'll have to have two critical value, one on the left minus 1.96, and the upper bound will be 1.96, positive 1.96. And let's see what else we have. The sample sizes, N1 is 35, and N2 is also 35. And X1 bar is also given. The mean leisure time spent by the first group, the age group of 26 to 35. This is 39.6 hours, and X2 bar is also it's 35.4 hours. So it's here the first group, and there you go. And the second group, then the sample mean for the second group is 35.4 hours for that age group. Okay, I also need to know the standard deviation of the variances from pre-studies And this is also given the population standard deviation. So sigma 1, it's not the variance are given now. Sigma 1 itself is given 6.3, and sigma 2 is also given as 5.8 hours. Okay, everything is given, so the calculated statistics can be performed easily. I'm gonna copy from there. Should be somewhere. Yeah, there it is. Gonna copy this, calculate the statistics. Yeah. Copy, paste it right here. There you go. This is the calculated statistics. And I'll substitute the result I have. Okay, 39.6 minus 35.4. And sigma 1 square is 6.3 square divided by 35 plus 5.8 square divided by 35, and this is within the square root. Okay, let's see the result of this. If I perform the calculation, let's see what I have. Yeah. Point 3 square divided by 35 plus 5.8 square divided by 35. Can make a mistake here. Yeah. My result is, you can check yourself also. If something incorrect, you can fix it at home. 2.9016 with 4 digits, the result I have. This is my result. Okay. Okay, and I have 2 critical values. I'll try to have the display of the Gaussian distribution and show you 2 critical regions. Yeah. One on the left, one on the right. Okay. This is project null. This is minus 1.96. And this is 0.025. And this is also reject the null. Reject the null. This is 0.025. There you go. And this is 0.95. 0.95. That is the area. You do not reject the null hypothesis. Do not reject the null. Okay. Okay, this is also here. I also have 1.96 on the right side, and the calculated statistics is simply falling within this part right here. Okay. Calculate statistics is 2.9016. Okay. Since 2.9016 is falling within one of the reject part, areas, the null hypothesis is rejected. It's alpha 4.45 level of significance. Okay. In other words, there is a significant difference. There is a strong evidence to tell that there is a significance difference in the average times each group spends. On leisure activities. Okay. This is the conclusion for this, and you can also try to have a confidence interval as well for the mean difference. So since there is a significant difference, we will definitely find out the lower bound, because the mean difference, the calculated statistic is positive. So we will have the lower bound positive and the upper bound is also positive if we try to have the confidence interval. Let's establish it. Establish confidence interval and 95% confidence interval for two means difference, mu1 minus mu2. So it's easy to do that. So can I bring you the confidence interval right here. Let's copy this and place it here. Yeah. There you go. Okay. Okay, so x1 bar is 39.6 minus 35.4 minus 1.96 times sigma 1 is 6.3 square divided by 35 plus 5.8 square divided by 35. This is within the square root, plus equal mu1 minus mu2 plus equal. Okay, I'm gonna copy the lower bound. Okay. There you go. And this is going to be a plus. The upper bound will be plus. Let me perform the calculation. Six minus 35.4 minus 1.96 times square root 6.3 square plus 5.8 square divided by 35. Okay, I'm mistaken here. Yeah, I've done it. Yeah, the lower bound is 1.36 30 plus equal mu1 minus mu2 plus equal, and the upper bound 7.0370. Okay, that's the confidence interval. You can easily tell that from the confidence interval, the null hypothesis is rejected. And we can also tell that we are confident, we are 95% confident to tell that the two mean difference is at least 1.36 and at most 7.037. We are we are 95% confident tell that the difference in the average times difference in the average times each group spends on leisure activities is at least 1.363 and at most 7.037. This is what we can tell for the confidence interval. That's the interpretation. You can also use the confidence interval. That confidence interval table can be used to test H null mu1 equals mu2 against versus H1 mu1 is not equal to mu2. I don't know whether I still have time. I'm running out of time. Okay, I have some minutes. I have 7 minutes. Okay. So you can use that confidence interval to test such hypothesis with alpha level. Since the interval, confidence interval, is not consisting the zero value, and we can reject the null hypothesis. Okay. Okay, if you have somehow given the interval, so since the lower bound is positive and the upper bound is positive, so the interval mu1 minus mu2 will not include the zero value. So it's easy to reject the null hypothesis. Let's have another example from the book. Let me copy another one. Let's see the solution. If you want to have the solution, I can also present you the solution as well. Let me copy the solution for you. It's 2.90. I found it 2.9016. Let me copy the solution of the book until here. Yeah, copy this until here. Okay. Copy this. Get to my section. Place it here. So this is the solution. Move it here. Resize this. Okay. Yeah. Then I have the graphical display. There's a display here, figure 5.93. Copy this. And step 5. Yep. There you go. Okay. Okay, this is step 5. So it tells you about the solution. And we have another one here. Let me copy this example and work out this example together. Another example. Okay. Look, we have another one. A researcher hypothesized that the average number of sport that colleges offer for males is greater than the average number of sport that colleges offer for females. A random sample of the number of sports offered by colleges for males and females is shown. At alpha 0.10 level of significance, the question is there enough evidence to support the claim? And assume sigma 1 and sigma 2 is given as 3.3. And so those are the given output in this table. Let's get the solution. Okay, so look at the claim. The claim is the average number of sports that colleges offer for males is greater than the average number of sports that college offer for females. So it's easily constructed. The null hypothesis can be constructed as HO mu male less equal mu females, and the alternative, that's the claim where you can include the claim in the alternative hypothesis, mu male, that's the claim, mu male is greater than mu female. And the alpha level of significance is 0.10. The critical value where you can find from the table I presented you. There you go. That's it. So for 0.10, since this is a right side, you can just have 1.28, the critical value. So I can easily have the critical value as 1.28. Okay. And what else we have? Let's see. You need the sample size for each group. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 in each column. 1, 2, 3, 4, 5. 5 by 10, and then 1 n male equals 50, and females is also 50. Okay. And what else we have? We have sigma 1 equals 3.3, and sigma 2 is also given as 3.3. And the other thing is, and we need to obtain, to test the hypothesis, we need to have the X bar for male and the X bar for females. The X bar for female. So it's easy to calculate. All you do, you sum up those 50 numbers